In a few moments, I want to show you an experiment that Ira Remsen carried out in about 1865-ish or thereabouts. I want to give you a little bit of background before we look at that experiment. Ira Remsen, whose picture you see here, along with Constantine Fahlberg, discovered the artificial sweetener saccharin. We know it is found in sweet and low, and you can see the chemical structure of saccharin next to it. And Ira went on to become quite a famous chemist. He was the second president of Johns Hopkins University. He'd been born on February 10th, 1846 in New York City. He died March 4th, 1927 in California at Carmel by the Sea. As a young man, he'd been educated at Columbia University and received the MD degree from Columbia University of College of Physicians and Surgeons. He also studied in Germany. He was quite an important chemist of the latter half of the 19th century and first half of the 20th century. In fact, he received the American Chemical Society's highest honor. He was awarded the Joseph Priestley Medal in 1923. And he also received the Willard Gibbs Award in 1914, so he's a very notable chemist. And so we're going to hear a story from Ira's memoirs that he wrote in first person. He's going to talk about copper, and you know a little bit about copper. It's a metal. It's hard. It doesn't shatter when you break it. You can pound it flat, which means it's malleable. We find it it's cladded on the outside of pennies nowadays. Pennies used to be made completely out of copper. The wire to our houses, the buildings, carries electricity. It can be pulled into wires, which means it's ductile. But as I mentioned, it's a good conductor of electricity. And it's a good conductor of heat. You might have some copper bottom pots or pans in your kitchen. So you know a little bit about copper before we see this experiment. Ira knew a little bit about copper before he does the experiment he's going to do. This experiment is also going to involve some acids. And you know a little bit about acids. You know of citric acid. We find it in fruits such as lemons and oranges. If you eat a lemon or an orange and you don't wipe your mouth off afterwards, you might have a little stinging sensation on your lips, for example. We also find acids in our stomachs. It helps us to digest our food. Lead storage batteries in our car, they use sulfuric acid. So you know a little bit about copper and a little bit about acids. So here in Ira's own words is the experiment that he undertook. This is about 1865. We didn't have the modern conveniences of the labs that we have, of exhaust hoods, or they didn't even have electricity in labs back in those days for lighting, and no indoor plumbing, no running water, etc. So with that background, here's Ira's story. While reading a textbook of chemistry, I came upon the statement, nitric acid acts upon copper. I was getting tired of reading such absurd stuff, and I determined to see what this meant. Copper was more or less familiar to me, for copper cents were then in use. I had seen a bottle marked nitric acid on a table in the doctor's office, where I was then doing time. In other words, he was studying. I did not know its peculiarities, but I was getting on and likely to learn. The spirit of adventure was upon me. Having nitric acid and copper, I had only to learn what the words act upon meant. Then the statement, nitric acid acts upon copper, would be something more than mere words. All was still. In the interest of knowledge, I was even willing to sacrifice one of the few copper cents then in my possession. I put one of them on the table, opened the bottle of nitric acid, poured some of the liquid on the copper, and prepared to make an observation. But what was this wonderful thing which I beheld? The scent was already changed, and it was no small change either. A greenish-blue liquid foamed and fumed over the scent and over the table. The air in the neighborhood of the performance became dark red. A great colored cloud arose. This was disagreeable and suffocating. How should I stop this? I tried to get rid of the objectionable mess by picking it up and throwing it out of the window, which I had meanwhile opened. I learned another fact. Nitric acid acts not only upon copper, but it acts upon fingers. The pain led to another unpremeditated experiment. I drew my fingers across my trousers, and another fact was discovered. Nitric acid acts on trousers. Taking everything into consideration, that was the most impressive experiment, and, relatively, probably the most costly experiment I have ever performed. I tell of it even now with interest. It was a revelation to me. It resulted in a desire on my part to learn more about that remarkable kind of action. Plainly, the only way to learn about it was to see its results, to experiment, to work in the laboratory. So that was Ira's discovery about learning what it meant for nitric acid to act upon copper. He burned his fingers, he ruined a pair of pants, but it created him a great curiosity that led him on to a great, great career. So to fill in a few blanks about nitric acid, it's a very corrosive acid. It's what we know as a strong acid. When you find it in the lab in the concentrated form, it comes as 15.8 molar, something that we'll learn more about later in the semester. It's a strong oxidizer, which means you just need to store it separately from other acids. And so it's not something to play around with, needless to say. And so what we saw happening was that copper, Cu is the atomic symbol for copper, was a solid, reacted with the acid, the nitric acid HNO3, which we can think of as H plus and NO3 minus, to make copper 2 plus, that's aqueous, that's what that AQ means, plus NO2, that's a gas, and H2O, that's water. And so the NO2 gas that you see, the nitrogen dioxide, that was that brown smoke that nearly asphyxiated Ira. And the copper 2 plus, that's when that copper is dissolved as an ion. It's no longer in the atomic metallic form. It's now an ion. It's lost a couple of electrons. It has a charge to it. And the blue color in the water that you saw in the beaker was the presence of that copper 2 ion. If you do some home gardening, you might use Miracle Grow. It's got a blue color to it that comes from the copper ion that's in it. If you've donated blood sometime, they'll test the density of your hemoglobin by putting in a certain concentration of copper sulfate solution. That's what that blue color is. And here you see again that blue solution that I just mentioned, and that copper penny that had started out with a brown color on it that is now the outermost layer has been taken off. It's a nice shiny color. So nitric acid acts on copper.